Perfect. So thank you so much again. And thank you, Peter, for coming to this seminar. And thank you for accepting my invitation. We have Peter Bainey with us. He is a legend in lots of areas, specifically in solar energy in Canada. And I had that privilege to work with Peter for almost 4 years. Is that right, Peter? 4 years?
Very close, yes.
Yeah. And it's my pleasure to have Peter with us right now. So Peter is going to talk about solar energy specifically, and also geothermal, and talk about the whole area of renewable energy in total as well. But if you do have any question regarding any technical part, you're more than welcome to ask any question at the very end of this conversation. So I do think that here's our agenda for today's meeting. At the beginning, we will go with the greeting and introduction that I'm doing it right now. Solar energy, all types, and all the thing that you're gonna need for solar energy in total. After that, geothermal energy. Government also have some incentives. Maybe Peter can help us with that part as well, and also talk about the job market in this area as well. But most part of this conversation, it's all about the technical parts, and I will ask Peter to start his talk. Peter, please.
Hello. My name is Peter Bainey. Thank you, Muhammad, for the nice introduction. Basically, in brief, I am honored to be here on the panel to share my experience with the group. I started my professional career back in 1980. And since 1980 up till now, I would say 41 years, my involvement mainly was in renewable energy. Started with, in the beginning with solar energy, convert solar energy to electricity back in 1980. And that was a job. I was a project engineer at Dalhousie, at Deltec. Back then, it was Nova Scotia Tech. So we did the first 1 kilowatt solar system to electricity back in 1980. And at that time, solar energy to produce electricity was very, very new. So it was the first project done in Nova Scotia back then. And immediately after that, we did a project for NBTEL, and it was New Brunswick Telephone Company, and it was the first project. Quickly after 1981, 1982, I quickly crossed to do solar energy in the thermal field, solar energy for the heating system. And also that was tapped into the new concept of seasonal storage. Basically, you collect energy during the summer, you save it in the ground to be reused in the winter. Back in 1980-81, that was a relatively new concept, which was under extensive research in Europe. And since that time, I have been also involved in solar energy, geothermal, in combination with thermal mass storage. Back in 2006, I did a big project in geothermal, as the screen is showing. That was called 5 Alderney Gate project. 5 Alderney Gate, because there was 5 buildings tied to this geo-energy system. And what you see in the picture is the vault where the mechanical room. And basically, this system has a feature that tap into the ocean to provide free cooling, also tap into thermal mass to be able to have cold storage as well. And that system was the first of its kind in Canada and probably in the world. So we kind of benefit from the ocean and the thermal mass available in the parking lot. As you could see here, Julian Ball was the engineer representing the municipality. And that's where that was this conference was arranged. UTES stands for Underground Thermal Energy System. I moved to electricity.
Is that the one that you're talking about? UTES?
UTES is the one we did Alderney 5 project.
Okay.
There is also another term, BTES. BTES stands for Borehole Thermal Energy System, which is this project combined both, which is the underground, really combined, I would say three parts: the free cooling from the ocean, the underground thermal mass, and the borehole technology. And in this project, we use an advanced, what we call coaxial borehole technology.
Peter,
which is
let
about
me
3 times.
stop you because I know that you have lots of technical things to share with us. But if you don't mind, let me start from the beginning and then move forward to that part, because I think, sometimes it's too much. So
Perfect.
Yeah. If you don't mind, I'm going to ask you to talk about the solar energy, because I know that the government of Canada has a big strategy and, I would say, ambitious to kind of like move forward to not use fossil energy at all. And, 70% of Canadians vote for renewable energy, and the government of Canada, they are moving forward toward to achieve this, I would say, percentage. So,
Mohammed, if I may add to your speech now, what kind of time frame we have now? What kind of time frame?
I do think that we do have 15 minutes.
15, 1-5?
No, 50.
50? 50. If I may suggest, let's open the floor for question and answer. That will be direct and effective with the participant. And at a later time, we could organize.
You want me to ask questions, or you want everybody?
You could ask question and the participant, because that will be direct benefit to all the participants, because directly will answer their request. This will be more. I would believe, in my humble opinion.
At the beginning of this conversation, you will talk about the area that you want to cover. But after that, maybe for 30 minutes or 25 minutes, we will open the mics and ask all the participants to ask any question that they want. Is that okay?
Yeah, it's okay. It's I could say the topics and we'll open the floor.
Okay, perfect. So, regarding the strategy that I would say government of Canada is looking forward, the main part of it is solar energy. And as you know, solar energy, the big part of solar energy is solar thermal energy. Could you please talk about this solar thermal energy at the beginning of it?
Yeah, I could talk about the system. Basically, the solar thermal system, you have a basic collector, solar panel, hot water, water circulates through it, pick up the energy from the sun and send it via a circulating pump to a storage tank. And that storage tank, from it, we deliver either to heat the house or use the domestic hot water for showers and laundry and so on. That basically the thermal solar system.
So in case, what is the seasonal storage in this case?
Seasonal storage is, for example, if you have a town and you want to put the whole town on a solar system, thermal solar system, so what you do, you create an area the size of a soccer field or football field, and you have some piping under the ground, and you heat the field during the summer. And winter time, you extract that energy and you heat homes during the winter. Just to give you an idea how powerful this approach, seasonal storage, if you, let's say, heat an area of a soccer field, let's say 20, 30 feet deep, probably for the whole winter season, you only lose 2 or 3 or 4 degree Fahrenheit temperature from the field. The amount of energy stored under the ground is huge. That's how the thermal mass storage, which we refer to it as seasonal storage, because you store the energy from one season to the next season.
Perfect. So before move forward, so what I'm gonna ask is that, okay, so seasonal storage is the thing that is like a mega project. It's not that small project that you're gonna do in residential area. Is that right?
Correct. It's a mega project. You wanna heat the whole town. It will be district heating system, let's say, and you have a huge area to store the energy. And to give you an idea, it will be the size of a soccer field.
Okay, perfect. So
that's the storage area.
Okay, so but I think I put it wrongly in this part. To be honest, sorry about it. But okay, so let's back to this solar energy. How does this solar energy works? You know, if all I know is the solar panel that we put it on the rooftop, and just get energy off it. Is that right?
Okay, that is two types. Some solar panels generate electricity, which they use the material silicon, right? And that is two types, polycrystal and monocrystal. And this is just monocrystal is more efficient, and that to generate electricity. The prices went down dramatically on those panels. 40 years ago, the cost of 1 kilowatt was about $20,000. Now the cost of 1 kilowatt is about $500. So the price went down incredibly. That to generate electricity. And basically, it's the technology. It's a semiconductor technology. When it's heated by the sun, it transfers the heat to electricity. So the other type of panel, the solar panel, which you circulate water through it, it has a basic, simple concept. It has a glass, and once the array of the sun penetrates the glass of the solar panel, the rays hit the pipe where the water is, and the heat is trapped below the glass. And basically, that type of glass is a special glass, low iron type of glass, so it kind of absorbs the sun. It doesn't reflect the sun, the area of the sun. So it stays there, and this way it warms the pipe. The temperature could easily reach 150, 160 degrees Fahrenheit.
Sorry to interrupt you, Peter. So the one that you're talking about is about the solar thermal energy. Is that right?
Correct.
Okay.
Yeah,
sorry, I put the wrong picture on it. Okay.
Yeah, solar thermal. But earlier I was talking about the other picture, the one that generates electricity.
Okay, so how much energy can we get from this one, from solar collector?
Okay, if we take the weather, let's say in Halifax, just to give you an idea, because I remember the number. For every meter square of solar panels, you could get 2.1 gigajoule per year for every meter square. And every 1 gigajoule is equivalent, I believe, equivalent to 277 kilowatt hour for every meter square.
So every gigajoule is 277 kilowatt per hour, and times
every one gigajoule is equal to 2.77. 2.1 times 277, that will be equal almost to 500 something kilowatt hours.
Okay, so
about 500 every meter square approximately give you 550 kilowatt hour per year. Okay. Every meter square.
Let's say 500. Okay.
Yeah.
Okay.
So for the engineers, every meter square, it give you about, let's say, 1 kilowatt hour per sunny hour. 1 kilowatt hour.
Okay.
Kilowatt hour per, every meter square give you 1 kilowatt hour.
Okay.
1 kilowatt hour. And in Halifax, we have 2,000 sunny hour per year.
Okay. 2,000 hour sunny.
Yeah, per year. And of course, there is the efficiency of the panel play a factor, and depend on how efficient the panel, you could reach a certain kilowatt hour value per year.
Perfect. You're right. So
I like to talk. I like to talk about.
Oh yeah. Sorry. Go ahead.
I like to mention about the thermal solar system. This type of solar system, it uses a circulator. If there is a pump, but also there is another type which we could use in a region where water doesn't freeze. It's called thermosiphon system. So basically, the tank is above the panel, and the solar panel become warm, and then the water circulates on its own. But solar energy in Canada, we add glycol, and that's why we need a pump to move it from the top down. Thermosiphon system is good like in the Middle East, in our part of the world, where you don't need a circulator. You put the panel, and the tank stand above the panel, so it circulates on its own naturally, and we refer to it as thermosiphon. And also, it's important to note, the tank should be 30 centimeters higher than the panel to eliminate the effect of reverse thermosiphoning. Reverse thermosiphoning is what you store during the day, you will lose at night. That's a good point to remember when we talk about thermosiphon system. Go ahead, Mohammed.
So regarding the solar collector, do you think that there is something that is kind of like as a general information? Do we know? Do we have to know something that you're kind of like missing, because we are going forward? And is there anything that left behind to talk about?
No, a solar panel, the thermal solar panel, there is a few different types. And like, for example, the solar heat pipe, they use a tube in it. You see them now. There is a different type. There is a type come from France. They use a freon in it. So there is different type. And that could take quite a bit to explain. But there is different type of solar panel.
To design these systems, a mechanical engineer who, how does this approach, come through? Do they have to kind of like match the design through with the budget, or how difficult is this, design?
You know, it's not difficult at all. You need to know what is your load, and you need to know what is your location. So you identify the capacity of the sun in that region, and you do basically calculation like simple return on investment, and you optimize your system this way. It is very economical to use solar energy.
And regarding this ROI, return of investment that you talk about, in Canada, we don't have that much sunny days. Is that right? Is that
what I find?
Yeah.
Sorry, what I find, you could get 5 years return on investment if a system well designed and well optimized. What I find, big systems are a good investment. For example, if you want to compare solar system for a home versus, let's say, an apartment building, you will find the maintenance part on the solar system for single home is much, much higher than an apartment building. So that's why the return on investment, if you take into consideration the maintenance part, you will find is two different scenarios.
So do you recommend solar thermal energy for single home family, like a residential single home, or you don't recommend it?
I would find if you want to compare solar energy compared to heat pump technology to produce, for example, hot water and heating, you will find the heat pump is very attractive.
Okay, perfect. Thank you so much. So let's move
You're welcome.
on. If anybody have any question, you're more than welcome to ask, because we want to move forward. Any question? Okay, so maybe they don't have any question. So let's move forward to the next.
Is it good or bad? Is it good or bad? I think it's good. I think it's good.
Yeah, I think you explained properly. So, Peter, regarding residential rooftop solar panels, that is very kind of like, they are advertising a lot during the sales, and I'm not sure, is that worth it to kind of like get this solar panel for my residential unit?
What I said earlier was about solar thermal energy. Photovoltaic system, which is the solar panel that generates electricity, is a bit of different scenario. For instance, if you think of, let's say, use a solar panel to generate electricity, and you look at the cost of electricity and the convenience of it, it could make sense in many situations. For example, let's say the solar panel is at about, let's say, 18% efficient now.
You said 18?
Efficiency, 18.
Oh, sorry.
Photovoltaic solar is 1/8.
I didn't know that much. Okay, so it's
it
1/8.
Low. This is a best scenario, good scenario.
Okay.
But let's say if you use solar panels to provide the electricity, and you use it to drive a heat pump, for example, and the heat pump has an efficiency or COP of 3 or 4, so you could see quickly that 18% to multiply it by 4. So what I'm trying to say, if you couple solar panels, photovoltaic system, to drive a heat pump, and a heat pump, let's say, to give you cooling, that will be totally free. So, and depend on the area and how much you are paying for electricity, that is a good combination between solar panel to produce electricity and heat pump.
So solar
really,
plus heat pump. is a
Solar
golden
to drive
combination.
heat pump. It is, and yeah, good combination, and it could be very economical, depend on the prices of electricity. Because
Okay.
you get electricity for free, and you multiply it by so many times, depend on the COP, especially if you need, let's say, cooling, and it's a must in certain area.
Okay, perfect. So
that's the market. If anyone interested, you need to target.
So let's give us an example. If I do have like 1 square meter of solar panel on top of my rooftop, how much can I get in the best scenario? How much should I get?
If you have 7 meters square, let's say 7 meters square, let's say this is 7 kilowatt, and efficiency of 0.2 or 0.18 to make it easy. So we have 1.4 kilowatt. 1.4 kilowatt, it could drive a heat pump. 1.4 kilowatt could drive a heat pump, which could give you, let's say, 4 times that value. Let's say we do in cooling, 3 or 4 times. So it gives you almost 1.5 ton of cooling.
Wow. That's
yeah.
That's
and
so
I'm
good.
doing quick calculation here. Pardon me?
Yeah, that's so good.
Yeah.
So 1.5 as a rule of thumb, every ton is
Yeah.
for 400 square feet. So
yeah, every ton is 12,000 BTU, right?
Yeah. Yeah.
And 1.4 kilowatt is about 5,000 BTU, right? Yeah. If you have COP of 4 on the heat pump or 3.5, that's about 18,000, 20,000 BTU. So this is 1.5 ton of cooling.
Yeah, 20,000 BTU.
Yeah, about 18,000 BTU is 1.5 ton of cooling.
Yeah, so basically it's good for let's say 600 square foot. I would say like apartment. Yeah. If they want to get cooling for that, I think it's enough.
For sure. Yeah. And now you could buy system actually come complete with solar panels and heat pump.
Wow. Okay. So
if I want to go back, I want to go back something for the participant to remember. So if what I'm saying is true, then you could use, in a way, the solar photovoltaic system to drive a heat pump to heat hot water. So your maintenance on thermal solar energy will come down really quite a bit.
So one of our participants asked for the difficulties that we might face for the maintenance of the systems, and specifically for the solar thermal units.
Tell you why it is the maintenance is high. First, it is the glycol. You have circulator, you have controller, you have control, and if the sensor malfunction, you have to go on the roof. If it's really, I find I did about 100 residential solar system for homes back in 1985. And I did about 10 huge commercial systems, like 150 unit apartment building. And I discovered the maintenance was the biggest problem for homes.
Okay.
I discovered.
So, Peter, correct me if I'm wrong. With this circle on the picture, it's a glycol that is circulating, and through heat transfer, it will send all this heat to the another circle that is not combined with this one. They are just
correct. Yes, correct. Yeah.
Okay, and the glycol that you're talking about is this one. Is it full glycol or a combination with water as well?
It is 50% propylene glycol.
Okay,
50%. propylene glycol.
Perfect. So, okay. Any other question? No. Okay, let's move forward. If we do have 25 minutes, we do in total, so maybe we can talk about this geothermal system maybe for 15 minutes, and then everybody can ask their question directly. How about that? Is that okay, Peter?
Yeah. I will be brief in describing, and hopefully in the question I will be more specific.
Okay, please go ahead. So, geothermal system, what is it about?
Okay, geothermal system is basically taking energy from the earth and heating or cooling a house. When we say heating or cooling, we use the technology of a heat pump to produce either heating or cooling, either way. So summertime, we are cooling the house and we send the energy to the ground to store the heat. Wintertime, we reverse the process. We take energy from the ground and we dump it into the house. There is quickly, I will say, there is a couple different type of geothermal loops. So there is what you call the U-tube. U-tube is exactly the U shape, water in, water out. Or there is the coaxial cable, pipe borehole, basically a pipe within a pipe. There are two pipes. And it seems from experience that the pipe within the pipe is more efficient. I would say probably 3 times more efficient than the U-tube.
So you prefer coax pipe, is that right?
Coax pipe, if you could imagine, there is a big pipe, 3-inch pipe, let's say, and there is another 1-inch pipe inside. Yeah, that's it, just like that. That's the cross section. Water goes from one line, in the middle one, and goes loop through the outside. Yeah, and also there is
this one, and then
come out from both sides. Come out. Yeah, perfect. Yeah, that's it.
Okay, Peter, correct me if I'm wrong. Regarding the principle of geothermal, I just wanted to kind of like correct me if I'm wrong. We do have a house. Let's say we are in the cooling season. Okay, we know that underneath of this, there's a line in the earth that when we go under that line, all the time, every time of the year, the temperature is around 10 degrees centigrade. Is that right?
That's correct.
Okay, so what we are doing is that, we are sending cold water, let's say cold water around, let's say 4 degrees to the ground, and try to heat it up for free and come back here to the heat pump, and with the help of heat pump and the compressor.
What happened?
Oh yeah.
Sorry if I may correct. When you are on the cooling mode, you are really sending 35 degrees Celsius, because what you do when you are taking the heat from the house and you are sending it to the pipe, and that temperature could be 35, even 40 degrees Celsius. It's not
35 degrees
or 40 even.
Oh yeah, sorry. Yeah, we are in the cooling. Yeah. I'm sorry.
So on the heating side, when you do the heating, then you extract from at that time whatever the average 30 degree, and you heat the house.
Okay, so we are dumping the heat to the ground when we wanted to do cooling. Is that right?
Correct.
So basically, when the water comes down through a very deep pipe down into the earth, in contact with the earth, is getting cooler. Is that right?
The air contact is in the house. In the ground, it is water and the earth around it.
Okay. So after that, when we bring this water on top, we are using heat pump and compressor to kind of like transfer this heat to the refrigerant. Is that right?
Yeah, the refrigerant, because boil at different temperature, it could quickly give you either cooling or heating, depend on the setting of the thermostat, how you want it. At any time, a heat pump system could give you cooling or heating at any time, summer, winter, at any time. And the ability to do this, because the Freon in it has different Carnot cycle, different characteristics.
You're completely right. So when we there are two types of loop, horizontal and vertical.
Okay.
What are the differences, and why we are doing this?
Horizontal loop, usually you could lay them below the ground at about 8 feet depth, and where you said it is about 10 degrees Celsius. That's correct. Vertical loop is the one shown in the picture. The vertical loop, there is a few different types. Vertical loop, there is the borehole type, like you could take and give in the same borehole, and there is also similar, but you have two boreholes. You have one on each side of the house, let's say. One of them will pump. They call that system a pump and dump. You pump from one end, you dump into the other borehole, the second borehole. So those are the two systems. And yeah, there is two different ways of doing it. Yeah.
I remember back in Halifax, Nova Scotia, we were I would say the only companies that we were doing geothermal system. So now, how attractive is this systems? For the I would say like for the owner of this big buildings, or for the investors, how attractive are they?
All of them are working really good. And all of them now, it's been almost 6-7 years, some of them. The payback period on those systems is at between 3 and 5 years maximum. We have incredible success with them. And, in the beginning, nobody were able to understand it. But now they are familiar with it. They, for example, through the whole summer, their energy bill is zero. It's really zero. Basically, whenever they are cooling the building, those apartment buildings, they are getting free hot water. It's really, it's an incredible concept. But like anything new, it takes time.
Sorry?
Yeah, it's, you could imagine the gas company are not happy here, because the whole 4 months during the summer, they don't come to the site. They don't give any gas to the, to those propane tanks. To have a joke, one of the drivers of those propane tank, he said, "My goodness, the technology! I'm glad I'm retiring this year. I don't have to worry about job security." But what I'm saying, really, it works. Those concepts work.
So regarding this geothermal system, one of our participants asked how to control these energies. Could you please explain a little bit more about this?
Well, it is basic control. We use simple control, and we use logic. And this is a long topic. And basically, we use scenario. We use different scenario, if this, then kind of statement in our program. And
that is go through BAS system.
Correct. Building automation system, but it is very simple. It's not complicated. We use certain algorithm that really take us through the different ladder logic to determine what we want to do. This is a good example of thermal storage and borehole technology.
Could you please explain more about this one?
This one, I could read ATS. This is more like a BTES system. BTES. And basically, the difference between BTES and ATS is the ATS is the aquifer thermal system. Aquifer, they refer to a lake beneath the ground where we pump from one end and dump at the other end. That's ATS system. But this picture shows a BTES system. And you could see the heat focused at the center of the geothermal system, where all the boreholes, and as you go away from the center, it gets cooler and cooler. And that's a BTES system.
So Peter, regarding ATS, you said that it should be a lake underneath of the...
Correct. Yeah, you pump from one end.
Is it hot or cold? How cold is that lake?
Usually at about 45, 50 degrees.
45
to 50 degrees. And you could say this is the lake here. And usually the line that goes in it is about 10-inch line. And you could pump, it's good like 300, 400 ton system.
Okay, perfect. So another question, Peter. What trades are involved for a complete geothermal project?
Mainly heating system, refrigerating technician that does freon. The difficulty in the business of this kind of business is very hard to find good technicians. Mm-hmm. That's the difficulty that we have. For example, in Europe, you have no problem. They are so advanced, they are ahead of us, they know a great deal about heat pump. In Canada, and I could speak for our area here, we don't have enough expertise in the area. And that's one of the reason I'm not kind of promoting a lot all those innovation that I have, because I cannot find good technical people to carry on the high level of business, of performance, of following up, and so on. That's my observation.
So I think you should train some of us to help you with your innovations.
Absolutely. We should have a special program within Nova Scotia Tech or the community college, because that is the truth. For a simple question, you cannot find a tech person that could answer it or understand it. And the only reason I am successful because I am also technically minded person. I did my first solar assisted heat pump 40 years ago. So I am, you could say, an engineer and also a technically minded person, as you would see when you were here. And I realized as I reach toward retirement, I have to really, you are one of the few that learned on troubleshooting, if you recall.
Yes.
Yeah, absolutely. It's a science by itself. Absolutely. Yeah.
Yeah, but thank you so much, Peter, for sharing this information.
You're welcome.
I hope.
I hope.
Yeah. Go.
I hope the participants were able to understand what I'm.
It's a very
maybe
complex, I would say, topic. But you know, if you go deep into it, you know, there are lots of questions. But you know, okay. So one of our participants asked, how much does it cost for 1 kilowatt in BTES system? So regarding the BTES system.
Okay, I will give you a good formula to use.
Okay.
If we are doing, tell you one thing I said earlier. Let's say if we are designing an apartment building, and we want to do geothermal in an apartment building. Excuse me. And what we are saying. Let's say I give you an example if somebody wants to take note, and that will be a good guideline. Okay. And for example, if we are doing 100-unit apartment building, 100-unit apartment building, and we want to put geothermal system, even though I want to explain by definition, geothermal is when you go 2,000 feet deep. This is known as the geothermal system, 2,000 feet deep. But now, if you want to go, let's say up to 500 feet, this is Earth's energy. It's not geothermal. Okay. This is the proper definition of that science. Geothermal is 2,000 feet. Earth's energy is up to 500 feet, I would say. Very, very shallow. So Earth's energy and thermal mass storage is kind of, they go together. Even though, as this picture, if it doesn't go 2,000 feet down, 500 feet, we should refer to it scientifically as Earth's energy. So if you want to go, let's say, 100 apartment unit building, and we want to go do geothermal or Earth's energy system, I would say as the construction is going, we placed a loop of high-density polyethylene pipe around the foundation. And basically, we save the cost of drilling or digging because it has been done anyway. So hardly any cost except laying the pipe around the building.
Instead of getting down, we just circulate the
just around the foundation. Okay. And usually because it's around 5-6 feet deep. And based on experience, it worked amazing. It is renewable. Let's say if the temperature was 40 or 50, you take energy from 50 to, let's say, 36 degrees, wait half an hour, it goes back to 45, 50. And this is life experience. And I will be more than happy to share it.
Let me ask again, because it's not a little bit clear for me. You said when you dump the heat with 50, it goes to 36. Is that right?
No, I'm not dumping heat yet. I'm just taking from initial state. State, I'm saying if the temperature is 40 or 50, if you take it and you brought it down to 35 degrees Fahrenheit. I'm sorry, I'm talking Fahrenheit.
Okay.
Now, or 10 degrees C. Let's say if it is 10 degrees C and we took it down to 3 degrees C. You wait half an hour, it goes back to 10 degrees C. So this will tell us it is renewable. It keeps coming back from the earth. That's what I'm saying. And that's a hand-on experience. So to go back to the question, how much costs 1 kilowatt? So what I'm trying to say, if that building need cooling, you could put, let's say, a 10-ton system. That ton system or 15-ton system will give you free hot water. And this way the client got his money back within 3 years, maximum 5 years. That's really a good numbers to work with.
Peter, just a rough estimation for that 10 ton cooling, I would say, cooling load. So
Yes.
how much is the investment like that, for that 100?
So if you do the math and you save, let's say, on hot water and free cooling, let's say if you save $5,000, if you do the math, your capital cost will be no more than $15,000.
Okay.
Or $20,000. So this gives you 3 years back period. So if you wanna bring it down to kilowatt, 10 ton is 120,000 BTU divided by 3,415 give you the number of kilowatt. You could work with those numbers.
You're right. So, but let me ask another question. So, if I wanted to design a geothermal system for 100 units, okay?
Yes.
As you mentioned, how much is the roughly estimation for the utilities, all the mechanical things, all the investment that they have to do for?
So let's say if we talk about 100 units, and let's say it costs $1,000 per unit to provide heating and hot water, let's say, right? So that's $100,000. And what I will advise, if you want 100% geothermal, you will find a payback period is long, 10 or 15 years maybe.
Okay, so it has to be a combination.
So it's not feasible. A combination. So let's say I want to save, let's say, for example, 60% or 70%, right? And I wanna invest, let's say, 300,000. I want to get my money in 3 or 4 years, and then the balance you use backup.
Okay. Yeah.
When it is extreme conditions. Yeah.
Mm-hmm. Okay. So I do have lots of questions. Okay. So are there any restriction by the municipalities for installing solar energy panels on top on the rooftop? Is there any restriction?
No restriction. No.
Okay.
No.
Type of panels. How many types of panel do we have?
Geothermal or photovoltaic, electricity.
For solar energy panel.
I think there is 2 types. There is monocrystal and polycrystal. That's monocrystal is more efficient, and basically because it's a full wafer, they call it silicon wafer. The poly is more like made of pieces.
Peter, none of them has any restriction?
No, it has to be like approved CSA. This is typical for any product. CSA or ULC.
Because I do have lots of questions. Could you please give me a short answer for this one?
All right. Okay, we'll do.
For number of panels, is there any restriction?
No.
Okay. For possible,
not that I know of.
Okay. Possible light reflection, are they covered, or possible light reflection? I'm not sure what does it mean by that. No. Okay, so are they?
I mean, they use a reflector with the panel. Maybe that's the question.
Okay, so do we require neighbors' consent for having, I would say, like a rooftop unit or something?
Not that I know of. Not that I know of.
Can they force us to remove the panel because of, I would say, like any I would say, violation, anything? No? Okay.
No.
Okay, so maybe, so what is the minimum kilowatt for BTES system to set up? Is there any minimum? Is there any?
No, usually for homes I use 5 ton. In my home, I have 2.5 ton. Usually 3 to 5 ton, but I have in my home 2.5 ton.
So
and it is 4,000 square
ask the
feet.
question again. So for BTES system, if I wanted to design the system, how much need do I have to go for this system? How much is the feasible minimum kilowatt to kind of like convince the client to go with this one?
Okay, I think that again, I could throw those numbers from experience.
Okay.
500 feet borehole, one is good for 3 tons. You will have no issue. 500 feet, 4-inch or 6-inch borehole is good for 3-ton system.
For 3 ton.
Yeah.
Okay. Okay. So it makes sense. Next question. Is there any kind of incentive to support from the federal or provincial government for the companies or project in renewable energy fields?
Yeah, there is a change from one region to another region.
So could you please just explain one of them, maybe in your region, just one of them, as an example?
Here in the region?
Yeah.
I tell you, to be honest, there is a lot of program on the residential level, but because I'm more like into commercial, I don't know the latest around here. I don't know the latest.
Okay,
but
so if they wanted to
and the
find
program
out,
changed. The program changed. Like for example, we have Efficiency Nova Scotia here. They have all kinds. So I kind of stay on the commercial side. And as you know, Muhammad, I'm almost slowing down. I'm retiring.
I know that.
I turned 65 in August, and
Peter, so if they wanted to find out about this this incentive, for example, in Nova Scotia, they can go for Efficiency Nova Scotia. Is that right?
Correct. And also, I heard the city HRM, they have a program.
HRM.
Yeah, HRM, they have a program as well.
Okay. So
for here. And different provinces, they have different. But also, I like to leave a good point for the group. You know, now our neighbor are all for climate change. So that business will be booming because Joe Biden is pro, environment.
That's a good news compared to, what Donald Trump did. Yeah. Okay, yeah. So what another question? Solar, geothermal, photovoltaic, which one has more opportunity to work now and in the short-term future? If I do have a very small company, which one would be the best, to kind of like put effort on it?
I truly believe load matching. If anyone knows what is load matching, if somebody say, well, I need 10 ton of cooling, right? I need 10 ton of cooling, but also I need 10 ton of heating. So that will be the perfect application for geothermal. This is what they call load matching. The cooling load matches your heating load. So your efficiency will go up to 700%. So if the group want to have interest in this technology, they have to focus on this market. Like an example, any apartment building, they want cooling and in some area, but also they have all year round use of domestic hot water, for example. Then that's a good application. Or even if there is 2 buildings next to each other, one building no matter what needs cooling, the other building need heating. So that's like a perfect scenario. If you have ice ring arena, if there is a building ice arena and there is next to it there is an apartment building, one could bring a project to the table, put both sides, on a round table and discuss a project. That's really where it is all win-win, and that is
because of your experience, and I had that experience to work with you. I know that you are always thinking about the big project, but if for small companies that they wanted to kind of like go and work on renewable energy area, which one do you suggest? Maybe solar energy? Which one has
solar energy, solar energy, photovoltaic? If they want to focus on using solar panel electricity to generate hot water, I believe that's the way of the future, because you don't have the glycol, and also the maintenance is very low.
Okay, so
that's really, it should be the focus.
Yeah, I do have millions of questions, so
that's good.
Yeah, I do believe that, Peter, maybe if you don't mind, let's set up another meeting, because there are lots of questions that I cannot ask you right now, and I know that you're a busy person. But if you don't mind, I want you, to promise to attend to another meeting maybe next week.
Muhammad, I give you my word, and it will be a pleasure.
Okay, thank you so much, Peter.
You're welcome, Muhammad.
I didn't have time to ask all of the questions, but if in case, if you wanted to be in contact with Peter, I can be the gateway. And if you have any question or anything, I can help you, to get connected with Peter Bainey. So thank you so much, Peter, for your time.
You're welcome.